Welcome back to the nest, everyone. This week we're going to be drawing for the free mug from all the people that have taken our free plan sample over the past 2 weeks. So good luck. I'll be drawing that in a few minutes. We're going to be doing a CozyCarb update. We will be showing some physical parts. We've now got the website functioning and whatnot. And I'm going to be asking and answering the 10 most asked questions about the CozyCarb. We're going to be doing an Electro-Thrust update. We have a new logo to roll out. Jonathan Barraclough's been working in California on the 3018 system, and it's going to be going into a north wing soaring trike. We'll talk about that. And the 5030 system will be developed right after that. And Bob Santom from CGS Hawk has graciously donated an airframe for the testing of that system. And lastly, we've got Algy Yates coming with his video number 5. He finishes the horizontal stab and the elevator in this episode. So here we go. This is Fisher Flying Products. I'm Dave Hartner. Welcome to the Nest. Our video newsletters provide weekly insight into building and flying our 15 wooden aircraft designs. Plini Motori of Italy is a gracious sponsor of our channel. Plini is the manufacturer of the Thor 250 DS. CozyCarb Ice Prevention Systems is a proud sponsor of this channel as well. Please take the time to watch our videos to the end, as this assists us in the metrics that YouTube uses to rate our channel. Hit the like button if you feel that the content is worthy. We invite you to subscribe to our channel by clicking on the subscribe button and hitting the bell so that you are notified whenever we post our newsletters. Well, we're going to begin things off with a draw for a free mug like the one up here. And I am got all the 43 names of the people who took the free plan samples over the last 2 weeks in my little bowl here. And so I'm going to pull one out. And here it is. Jeff Akins of Texas. So Jeff, you've won a free mug from Fisher Flying Products, and we'll be in contact with you to get your shipping information to get that down to you. So congratulations, Jeff Akins. Next, I want to go on to CozyCarb update. So we have been moving right along in getting the CozyCarb pieces manufactured, and I've got a one right here, and maybe you can see it against my shirt, but basically this is the 912 CozyCarb unit, where coolant goes in through here and around and then back out again. And so this piece here gets press fit onto the carburetor, and it has an identical flange as the carburetor does. And so therefore when you fit the carburetor in here and then seal it and lock it to it, then you can take this piece and put it into where the carburetor would have normally sit. It's a 17 millimeter offset. It runs with the coolant system, and the coolant runs through it and heats the carb body all the time. And you never have to turn it on. You never have to remember to turn it on. And so CozyCarb is well on its way. So we had to take the components, the casting pieces or the casting dies from the UK that we purchased, get them to our local casting guys, get these made up, and we've got a bunch made now, and they're all ready for sale. So the other one that we sell is a unit for the 582 style engines, two-stroke engines, liquid-cooled two-stroke Rotax. And we've changed those just a little bit from having two fittings that would be screwed into each side of here and a tract for the coolant to go through to a different style where we over drilled this hole just a little bit, and we fit a piece of solid tubing all the way through, and that eliminates two joints that you would have that could be a possible point of failure. So now you only have one hose goes on here, clamps on, and there's only one joint. You can't have a leak from the fitting threads or anything like that. So this is the other CozyCarb piece, and it's a machined piece, and we sell both of those. And so we've got a new website, which I'll pull up here. The new website is a very interesting cloudy design and whatnot, www.CozyCarb, and it tells you all about the two different styles. And if you want to purchase them, you just hit purchase button on the CozyCarb site, and it will take you to our Fisher Flying Products web store. where you can actually purchase the units, and then we'll deliver them. So I'm happy to say we've gotten through all of the preparatory work to get the CozyCarb kits ready for sale, and they're ready to go. So that's good news for that. I'm going to give you an Electro-Thrust update as well. We have a new logo developed for Electro-Thrust propulsion systems, as you can see on the screen. Kind of a nice battery logo with a motor insignia and a propeller. I thought it was nice to show them kind of in motion. An update from Jonathan Barraclough, who is our sort of retired NASA engineer, electrical engineer, who's developing their systems for us. He's got the 3018, which is 30 kilowatt peak, 18 continuous system, ready for testing, and we're waiting on a North Wing soaring trike to be delivered to him so that he can fit the system in that, and then he'll take it out to the desert and literally test fly it in the desert on the flats in the desert and put it through its paces. But we're ready to go with that. And then I wanted to let everyone know that Bob Santom from CGS Hawk has graciously offered up one of his aircraft for testing the larger 5030 system, and it'll go in to replace a 503, 582 kind of setup. And so we're kind of jazzed that he's offered that up, and he's also going to be carrying some of our products once they are developed. So thank you, Bob. And lastly, I just wanted to say again, thanks to Algy Yates for all that he's done. He's put together very nice videos, and I'm getting a lot of super comments on them. And so without ado, here we go. Algy Yates and his build number 5, where he finishes up the horizontal stabilizer and elevator.
Welcome to the channel. In this video I complete the tailplane to the point where we could fit hardware, and towards the end of the video I will discuss my modification, my reasoning behind it. So let's get cracking. To make up the blocks, I've put in a stop here, so I can just go in, run the saw, cut a section off, turn it over and cut some more. So here we go, we'll get some blocks cut. Okay, so I need to cut this rib, so I'm just going to put my gauge in, tighten it up, and that's 50 degrees. So the rib piece is going in like that. I can just align that onto the side there. I can mark it. I'll cut that. So with the first cut carried out, runs across. I need to move this clamp slightly out of the way. Now I've got that in position there, sighted down. I can now mark on here where it intersects. I can transfer the angle onto there. I'll cut that little piece off, and we'll double check and use a sander just to get it to match perfectly. So here I have a new tool to me, little sanding setup. I'm just going to use that to take this line, or take the wood back to this line here, so it should fit perfectly. I'll leave a little bit of line, we can do a bit of adjustment if needed. So that's just back, so the line's just showing. Just for your information, I did check that this the bed here is set at 90 degrees using a square to make sure everything's perpendicular. So when I sand here, that is at 90 degrees and ready to go. Let's see how we got on. So hopefully you can see that that fits nice and parallel. The joint is spot on, very, with it lined up. There's enough room for glue. It's running along the, if I move that, you can probably see the line. It's parallel with that line there, and we are ready to go. Just a quick view, all the clamps in place after gluing it all together. Taking out all the blocks so we can release the elevator. Now I'm just setting up the router here so I can do the gussets same way as I did on the horizontal stabilizer, just marking out the positions where the gussets are going to go. And here we are cutting gussets using the Stanley knife, giving it a light sand, make sure the edges are good. It takes a little bit of time, but it's not that onerous. Here's the jig in position, and I'm starting to do the routing down. Now, some people concerned about the fact that you're taking material away from the wood frame that's already there, but you're only taking, in this case, a 1/16 of an inch out either side, and that's being replaced by the plywood. And the plywood takes the shear loads for the glue joint. The normal glue joint with end grain going onto the side grain of a piece of wood hasn't got much in the way of strength in the tensile line, and the gussets take the load through and puts a shear load on the glue line, which the glue can cope with a lot better. So they do make the joints much stronger. The wood joints can cope with compression and to a certain degree a little bit of torsion, but ideally they take that shear load is the best way to make a joint strong and lasting. The other advantage of having sunken gussets that don't show through the covering is you don't put hard points into the covering, which can wear the covering, and also it affects the aerodynamics of the aircraft to a degree. So all in all, it's much better to have these sunken gussets, in my view. Here I'm just blowing off the any dust from sanding. I do that before I do any of the gluing. It aids to make a stronger joint, because with a thick resin such as T88 it tends to sit on top of dust. And you can still see I'm putting this plastic sheeting down. It's plexiglass, thin plexiglass, over the joints before weighting it. That spreads the load and keeps the gusset flush with the top of the wood frame. So now all dried, I'm going around. This is an edge router, just removing the excess from the gussets to bring everything back to the frame. And I'm just doing a little bit of sanding to get rid of the edges there. And here we go, clearing up the workbench before I do the edges of the elevator. Changing the routing bit, setting it up, and here I am using the round over bit, just cutting back the initial cut for making a sort of semicircle around the trailing edge. Cutting off the excess, sanding it so it's flat against the other piece, and now I'm using a 45-degree bit just to cut into the V in the elevators there, and we'll talk about that in a bit more detail shortly. You've just seen on the time lapse I've routed around the edge here. I cut off the excess and then I've routed down here with a 45-degree, much smaller, because I'm not going to round this area off as much. I don't want it doesn't need to be fully rounded. I just want to take off the corners. But the important thing is, you see I've put this piece of wood here. This piece of wood, it was to stop the router from over travelling. And if I take it out, the idea is that where the rounding section goes to, it's in line with the back of the spar, you know, so that we're not actually cutting into the spar. This section here takes a lot of torsional load, so I don't want to cut into that. So I've literally just routed back there without taking too much material off, just to get a rounded edge there to help the covering later on. It's give you an idea how much it's actually gone back. It's gone back less than the thickness of the laminate, so less than 1/8 of an inch is what we've gone in. In fact, the width of the 45 is still slightly less than 1/8 of an inch. So I've just taken a small amount off there, and this of course is are rounded to nearly, I don't know if that's in focus, you can sort of see the small bit which I sort of left for where the wheel is going to go around on the router round over bit. So I've now just got to sand and cut off these excesses at the end, and that'll be this finished to the point where we need to get hardware and do beveling for hinges. So catch you in a bit more time lapse. So here I am, I'm just doing the sanding at a shallow angle to get the bit that the round over bit didn't get, and then we'll do some strap sanding to round it off. Doing that with 180 grit, and here I'm just using the block. The whole tail plane is complete, elevator and horizontal stabilizer. Just let me show you the points. I matched here the tip of the horizontal stabilizer with the elevator. There's about a 1/16 of an inch, maybe an 1/8 of an inch had to come off at both ends. Just slightly less than the thickness of a lamination, so. And at the moment I've just got this strip of wood here representing the hinge thickness, just to help me align that. As discussed, I lightly rounded here to try and keep as much material in as the torque being transferred from the horn that would be affixed to the spar is transferred out to the trailing edge through these sections and through the ribs, so trying to keep this lot strong. These joints here and here really are critical joints for transferring that load, along with all the joints against the spar, so make sure you take your time to make those joints as good as possible. Not quite so critical out here on the trailing edge, but still full strength, good to make as best as you can. Right, so to the modification which I have carried out to the elevators on my Youngster Tail plane. For those of you who are sharp-eyed, you'll notice there's no trim tab fitted to the elevator. This is not an approved modification by Fisher, but I have my reasons behind it, and I'll try to explain these to you. If you are flying an aircraft with the centre of gravity towards the forward limit, and you want to trim up elevator to compensate for that, the trim tab goes down to raise the elevator. When you come to flying slowly and into the flare for landing, that reduces the amount of effective control surface that you are deflecting upwards to do the flare. Although the trim tab is not enormous on the Fisher tail, neither are the elevators, so I'd like to try and get past that for starters. Second reason is weight. By the additional framework, which is made out of the heavier material, and having hinges to articulate the trim tab and horn to operate it in cable, I estimate that the weight on the elevators is around 12 ounces, 10 to 12 ounces. So that is a significant amount of weight moving the centre of mass of the elevator back, which in a higher performance aircraft could cause flutter. No reports of this have been made for the Youngster, and I'm sure it's not actually a problem, but that 10 to 12 ounces of weight is a long way back on the moment on the aircraft. So if I use this aircraft as an example, my model, the centre of gravity would normally be around here. By adding weight back here, it's got a long moment, and so tends to make the aircraft tail heavy, or move the centre of gravity back significantly with a fairly small amount of weight, unlike having weight on the nose, which has got a short moment, so it has less effect. So for me, I want to try and remove that weight from right at the very back of the aircraft, and if I'm going to need weight at the back of the aircraft, I can utilise that better in things like the tail landing gear or something in that format. So how am I going to trim the aircraft? Well, I'm looking at producing a trim system that's going to operate on the joystick or control run with springs, as has been used in many other aircraft. So I'm reducing the complexity, I'm reducing the weight at the back end of the aircraft and the possibility of it encouraging flutter, and I'm increasing the effective control surface at full deflection. So those are my reasons behind it. It is my choice, and if you were to go down the same line, that will have to be your own personal decision. Always, whenever you're carrying out a modification, think about the safety implications and what is going to happen as a secondary result of that. So, hope you enjoyed the video. In the next video, I plan on working on the fin and rudder system. So, join me for that. Bye now.
Thanks again for watching. We try hard to bring you interesting content each week. To help us out, please like and share our videos if you feel the content is worthy. To receive the latest info from Fisher Flying Products, click the subscribe button and ring the bell. See you next time in the nest.